titanium 4 chloride can be made by titanium 4 oxide as shown in the equation. And then we've been given entropy data, S values. It says use the equation and the data in table 3 to calculate the Gibbs free energy. So the first thing we need to remember is that to calculate Gibbs free energy, delta G, then we need to do delta H minus T delta S. When we've been given the delta H here, we've been given the temperature here, we're going to need to calculate delta S from the table. So delta S is the sum of the entropies of the products minus the sum of the entropies of the reactants. So let's do that. So the sum of, we'll do a big bracket. So we've got products, 2 carbon monoxides, so 298s, and 1 titanium 4 chloride, 253. And we're going to minus the sum of the reactants, 1 titanium oxide, 2 carbons, 5.7, and 2 chlorines, 223. So we type all that into our calculator. And when you do that, you should get 141.4. Now be careful, remember the units up here, joules per Kelvin per mole. Okay, so we have a number now for delta S, but we do need to remember that delta G is given in kilojoules per mole, and so our delta H is already in the right units, minus 60, and our temperature is not in the right units because that's in degrees C, so we need to add 273 to that to get that into Kelvin, and that becomes 1262 Kelvin. So that's 1262, and then we need to times it by our delta S, which was 141.4, but that was in joules and we need it in kilojoules, so we're going to convert by dividing it by 1,000. Type all that into our calculator. And we're getting an answer of minus 238. It says give it to the appropriate number of significant figures. And the numbers are all given to 3. So this is minus 238 kilojoules per mole. And then we need to go back and see what we've got these lines for. Use your answer to explain whether this reaction is feasible. So our delta G is less than or equal to 0. It's negative. Yeah. So the reaction is feasible. Delta G needs to be negative for it to be feasible. And this one will be feasible.